There is a silence in the cosmos so profound that it aches. Yet, within that silence, pinpricks of mystery beckon, a flicker in the darkness, a spectral glow where none should be, the chemical fingerprint of an atmosphere rewritten by unknown hands. As the Earth turns beneath the sweep of radio telescopes and orbiting observatories, a new epoch of inquiry unfolds, a search for the hidden, the lost, the perhaps never was. The exoplanets we now catalog by the thousands are not merely numbers in a ledger, they are stories waiting to be told, some of them perhaps written by civilizations that have long since vanished, their only memorial the altered breath of a world or a signature of energy echoing across the gulf of time. The human journey to this threshold is itself a story of restless longing. For centuries, the night sky was a canvas of imagination, the planets mere points of light, and the stars distant, unreachable suns. The question, are we alone? Haunted philosophers and poets, priests and astronomers, Giordano Bruno, burned for his heresy, dared to dream of infinite worlds, each warmed by its own sun, perhaps peopled by minds as curious as ours. The Copernican revolution decentered the Earth, but it was the advent of the telescope, and later, the spectrograph, that first allowed us to probe the distant atmospheres of other worlds. The first confirmed exoplanet, 51 Pegasi b, revealed itself in 1995, a hot Jupiter whipping around its star in days, upending expectations. It was a harbinger of the strange. The Kepler mission, launched in 2009, transformed the trickle into a torrent. Astronomers sifting through the faint dips in starlight found planets by the thousands, rocky, gaseous, temperate, scorched, and frozen. Some, the so-called super-Earths and mini-Neptunes, defied easy classification. The galaxy, it seemed, was crowded with worlds. But discovery is not understanding. To discern the nature of these distant orbs, astronomers turn to the subtle art of spectroscopy. Every element imprints its own signature upon the light that filters through an atmosphere. Oxygen, methane, water vapor. Each is a clue, a potential marker of life. Yet life is not the only force that changes a world. Technology, too, leaves traces, if it is sufficiently advanced or heedless or desperate. The search for biosignatures thus merged with the search for technosignatures, the chemical or energetic fingerprints of industry, of artifice, of intention. It is here, in the borderlands between biology and technology, between nature and artifice, that the strangest signals have begun to emerge. In the data from Hubble, Spitzer, and more recently, the James Webb Space Telescope, planetary atmospheres sometimes reveal chemical imbalances that seem, at first blush, impossible to explain by natural processes alone. In the archives of radio telescopes, Arecibo, Greenbank, Parkes, there are bursts and whispers that resist easy classification, their origin neither fully mundane nor obviously artificial. Consider the enigma of KIC 8462852, Tabby's star. Discovered in 2015 by Tabitha Boyajian and her team, its light curve is a thing of nightmares and dreams. A star whose brightness dims by as much as 22%, with no regular period and no clear cause. Comets, dust, occulting clouds, all have been proposed, yet none fits the data perfectly. Jason Wright and others have dared to suggest a more radical explanation. Megastructures, perhaps the shattered remnants of a Dyson swarm, built by a civilization now gone, their shadow the only testimony to their existence. The idea is almost certainly wrong. Nature is subtle, and our ignorance vast, but the possibility lingers, a ghost at the feast. Elsewhere, the atmospheres of distant exoplanets whisper their own riddles. In 2019, the Hubble Space Telescope found water vapor in the atmosphere of K2-18b, a super-Earth 124 light-years away. The planet lies within the habitable zone of its red dwarf star, a region where liquid water could persist, yet its atmosphere is thick, hydrogen-rich, more akin to Neptune than Earth. Is it a failed world, or could life have found a way to thrive with chemistry utterly alien to us? Or, stranger still, could the peculiar mix of gases, water, methane, ammonia, be the legacy of technological intervention, a biosphere modified by design rather than evolution? In the spectra of WASP-33b, an ultra-hot Jupiter, astronomers have found titanium oxide and vanadium oxide, molecules that could only persist in the wild furnace of a world heated to thousands of degrees. These compounds, rare on Earth, are common in the atmospheres of certain stars but unexpected on planets. Their presence raises questions about atmospheric dynamics, but in the fevered imagination of some, it also suggests the possibility of deliberate engineering, perhaps to regulate temperature or harness energy. The search for technosignatures has taken on new urgency in the wake of these discoveries. In 2014, the Breakthrough Listen project began a systematic survey of the sky, using the world's largest radio telescopes to search for narrowband signals, pulses, or modulations that could not be explained by natural astrophysical processes. The results so far have been equivocal. Most candidate signals are quickly identified as human-made interference or natural phenomena or artifacts of instrumentation. Yet, every so often, a signal emerges that resists explanation. The WOW signal of 1977, detected by Jerry Amon at the Big Ear Radio Observatory, is the most famous, a 72-second burst at the hydrogen line, never repeated, never explained. Was it a glimpse of a vanished civilization, flaring briefly before falling silent forever? Or was it, as some suggest, a passing comet, or a terrestrial echo, or something else entirely? The question is not merely academic. If civilizations rise and fall in the galaxy, their traces may be subtle, diffuse, detectable only as the faintest of anomalies. In 2018, Adam Frank, Jason Wright, and colleagues proposed the concept of exo-archaeology, the search for the fossil record of technological civilizations, not in artifacts but in atmospheric or energetic signatures. A planet with a modified atmosphere, excess chlorofluorocarbons for example, or nitrogen oxides or other industrial byproducts, might betray the presence of industry, even long after the civilization itself has vanished. The half-life of CFCs on Earth is measured in decades, but on a planet with no active biosphere or weather, such molecules could persist for millennia, their spectral signature a memorial to lost minds. The search for these signatures has become increasingly sophisticated. The James Webb Space Telescope, launched in December 2021, is capable of detecting the faintest traces of complex molecules in the atmospheres of distant worlds. Its first observations have already revealed the presence of carbon dioxide, methane, and even hints of sulfur dioxide on exoplanets dozens of light-years away. In the near future, missions like Ariel and LUVOIR will extend this capability, enabling the direct imaging and spectral analysis of Earth-like planets around nearby stars. Yet the interpretation of these signals is fraught with ambiguity. The false positive problem looms large. Many molecules that might indicate life or technology can also be produced by abiotic processes, volcanism, photochemistry, impacts. The discovery of phosphine in the clouds of Venus, announced in 2020 by Jane Greaves and her team, was initially hailed as a possible indicator of microbial life, only to be thrown into doubt by subsequent analyses and alternative explanations. The universe, it seems, is adept at mimicry. This ambiguity has shaped the philosophy of the search. In 1960, Frank Drake formulated his famous equation, an attempt to estimate the number of communicative civilizations in the galaxy. The equation is a litany of ignorance: star formation rates, the fraction of stars with planets, the likelihood of life, intelligence, technology, longevity. Each term is a chasm, spanned by our best guesses, our most optimistic or pessimistic assumptions. The silence of the sky, the Fermi paradox, lurks at the heart of this enterprise. If civilizations are common, where are they? If they are rare, why is that so? Are we the first, the last, or merely the next in a long, unbroken line? To address these questions, some have turned to the study of planetary atmospheres as records of history. The Earth itself has undergone dramatic transformations: snowball episodes, hothouse epochs, mass extinctions. The rise of oxygen, 4 billion years ago, was the product of microbial metabolism, but it also nearly spelled doom for the anaerobic life that preceded it. Our own industrial age has left a chemical scar: rising carbon dioxide, synthetic pollutants, radioactive isotopes. If we were to vanish tomorrow, how long would these traces persist? Would a distant astronomer, 1,000 years hence, detect the afterglow of our industry, the spectral signature of our brief tenure? The search for such afterglows has inspired new missions and new techniques. In 2022, a team led by Ravi Kopparapu at NASA Goddard proposed targeting the atmospheres of exo-Earths for signs of industrial pollutants, molecules with no known natural source, such as certain chlorofluorocarbons or perfluorocarbons. These compounds absorb infrared light at specific wavelengths, creating a fingerprint that could, in principle, be detected by future telescopes. The challenge is sensitivity. Even with the most advanced instruments, it would require dozens or hundreds of hours of observation to tease out these signals from the background noise. But the reward is immense. To find a world with an atmosphere altered in such a way, where the chemical ratios defy natural explanation, would be to glimpse not just life, but technology, and perhaps its aftermath. It would be to read the obituary of a civilization written in the air of a distant planet, to know that we are not the first, nor the only, to strive and to fall. Yet the signals we seek are not always so clear. In some cases, the anomaly is energetic rather than chemical. The search for Dyson spheres, vast structures built to harvest the energy of a star, has a long pedigree. In 1960, Freeman Dyson proposed that an advanced civilization might surround its sun with a swarm of satellites, capturing the bulk of its energy output. Such a structure would radiate waste heat in the infrared, creating an excess that could, in principle, be detected by telescopes. Surveys of infrared sources, most notably using data from the Infrared Astronomical Satellite, IRAS, and the Wide Field Infrared Survey Explorer, WISE, have identified thousands of candidates, but none has yet withstood scrutiny. Most are natural, dusty stars, galaxies, young stellar objects. Still, the possibility remains. In 2015, a team led by Jason Wright examined the light from KIC 8462852 for infrared excess, hoping to find the signature of waste heat from megastructures. The results were negative. No excess was found. But the mystery of the star's dimming remains unresolved, a reminder that our models may be incomplete, our imaginations too constrained. Other energy anomalies are even more enigmatic. In 2020, astronomers reported the discovery of fast radio bursts, FRBs, millisecond flashes of radio waves from distant galaxies, some repeating, most singular. The origin of FRBs is a subject of intense debate. Neutron-star mergers, magnetar outbursts, the collapse of massive stars. Yet some have speculated that these bursts could be the byproduct of alien technology, perhaps the propulsion of light sails, as suggested by Avi Loeb and his colleagues. The evidence is circumstantial at best, but the sheer power of these events, comparable to the energy released by the sun in a year, compressed into a blink, begs explanation. The search for exoplanetary anomalies has thus become a multidisciplinary enterprise, blending astronomy, planetary science, chemistry, engineering, and even anthropology. The study of Earth's own atmospheric and energetic history provides a template, but also a caution. Our ignorance is vast and nature is inventive. The challenge is to distinguish the artificial from the natural, the signal from the noise. To do so requires not just technological prowess, but humility. The history of science is littered with false positives. Canals on Mars, pulsars mistaken for little green men, the Martian face revealed as a trick of shadow and resolution. Each anomaly must be probed, dissected, explained, or discarded. Yet to explain too quickly is to risk missing the truly strange, the outlier that changes the paradigm. At the heart of this search is a paradox. We seek evidence of intelligence, yet we do not know what it might look like. Our own technological trajectory is but one of many possible paths. Would an ancient civilization, facing ecological collapse, choose to preserve its world or transform it beyond recognition? Would its monuments be visible at interstellar distances, or would they fade, leaving only a chemical or energetic echo? Is technology, like life, an adaptive response to circumstance, or an aberration, a brief flash destined always to burn out? These questions are not merely speculative. They shape the design of our instruments, the algorithms that sift the data, the hypotheses we test. They also shape our sense of ourselves, as possible inheritors of a cosmic legacy, or as the first to awaken, alone in the darkness. The search for vanished civilizations is thus an act of both science and imagination. It is rooted in the hard data of spectra and light curves, but it is also animated by the hope that we are not alone, that the universe is not indifferent, that meaning can be found even in absence. Every anomaly, every unexplained signal, is a whisper from the past, an invitation to listen more closely, to look more deeply. Consider for a moment the story of Gliese 581. In 2007, astronomers announced the discovery of a planet orbiting a red dwarf star 20 light-years away within the habitable zone. Subsequent studies found hints of water vapor, perhaps even clouds. Some speculated that the planet might be Earth-like, a haven for life. Yet later analyses cast doubt on its very existence. The signal may have been an artifact, a false positive. The lesson is sobering. The cosmos is filled with mirages, and certainty is always provisional. Yet, even the failures teach us. Each anomaly, explained or not, refines our models, sharpens our tools, expands our sense of the possible. In the case of Kepler 438b and Kepler 442b, two Earth-sized planets in the habitable zones of distant stars, the search for atmospheric signatures continues. The detection of oxygen, methane, or other biosignatures would be a triumph, but only if we can rule out abiotic production. The same is true for technosignatures. The line between the artificial and the natural is not always clear. The future of this search lies in the convergence of technology and theory. Advances in machine learning and data analysis allow astronomers to sift through petabytes of data, searching for patterns that might escape the human eye. The Vera C. Rubin Observatory, set to begin operations in the coming years, will generate an unprecedented stream of observations, mapping the dynamic sky with exquisite precision. The next generation of space telescopes, LUVOIR, HabEx, Origins, will have the sensitivity to detect the faintest whispers of life or technology in the atmospheres of nearby exoplanets. Yet, the ultimate limitation may be philosophical as much as technological. Our assumptions about life, intelligence, and technology are shaped by a single example: ourselves. We search for what we know: oxygen, water, chlorofluorocarbons, radio signals, megastructures. But the cosmos may harbor forms of mind and method as yet undreamt. The challenge is to remain open to the truly alien, to recognize intelligence even when it wears a mask we do not expect. This openness is not without risk. The human mind is prone to pattern recognition, to finding meaning in noise, to seeing faces in the clouds and messages in the static. The history of SETI and exoplanet research is replete with examples: false alarms, misinterpretations, wishful thinking. The task is to balance skepticism with wonder, to demand rigor without closing the door to possibility. In this spirit, the search for exoplanetary anomalies continues. Each new discovery, a planet with an atmosphere out of equilibrium, a star with a light curve that defies explanation, a burst of radio waves from the edge of the observable universe, is a data point in an unfolding story. The narrative is never complete, always provisional, always open to revision. Yet even in the absence of definitive proof, the search itself is transformative. It forces us to confront our place in the cosmos, to imagine histories older and stranger than our own. It invites us to see ourselves not as the center, but as a part, as inheritors of a legacy we do not yet understand, as potential ancestors to civilizations yet unborn. In the end, the question of ancient vanished civilizations is as much about us as about them. It is a mirror reflecting our hopes and fears, our aspirations and limitations. The search for their traces, modified atmospheres, strange signals, energy anomalies, is an act of remembrance, an acknowledgement that we, too, will one day be gone, our own traces fading into the background noise of the universe. But perhaps that is enough. To search is to care, to remember, to bear witness. In the silence of the cosmos, even the faintest whisper is precious. The exoplanets we study, the signals we chase, the anomalies we puzzle over, they are the echoes of possibility, the shadows of minds that may have once gazed at their own skies and wondered, as we do, if they were alone. The search for exoplanetary anomalies is thus both a scientific endeavor and a moral one. It asks us to look beyond ourselves, to imagine lives and histories other than our own, to recognize the value of difference and the inevitability of loss. It is an act of humility and of hope, a refusal to accept silence as the final answer. As we peer into the atmospheres of distant worlds, as we sift the data for patterns and anomalies, we are also searching for ourselves, for a sense of connection, of continuity, of meaning. The universe may be indifferent to our hopes, but we are not indifferent to its mysteries. In seeking the traces of ancient civilizations, we affirm our own capacity for wonder, for empathy, for remembrance. And so the search continues. Each new generation of instruments brings us closer to the threshold of discovery, or of confirmation that we are, for now, alone. Each unexplained signal is an invitation to look deeper, to question our assumptions, to expand our sense of the possible. In the end, perhaps we will find nothing but nature, no monuments, no signals, no memorials but the rocks and the clouds. Or perhaps in the spectrum of a distant planet, in the flicker of a fading star, in the echo of a radio burst, we will find the signature of minds that once were, ancient, vanished, yet present still in the fabric of the cosmos. In that moment, the silence will be broken, not by words, but by understanding. We will know that we are part of a larger story, that our own striving is mirrored in the histories of worlds beyond our own. The search for exoplanetary anomalies is, in the end, a search for kinship, a recognition that, whatever our fate, we are not alone in the universe's endless night. As the telescopes turn, as the data streams in, as the algorithms sift and the theories evolve, the story continues. The strange signals, the modified atmospheres, the energy anomalies, they are the signposts of a journey without end, a quest for meaning in a cosmos that is, by turns, indifferent and sublime. In that quest, we find ourselves, not alone but together, searching, listening, remembering. The silence is not emptiness, but possibility. The darkness is not absence, but invitation. The universe is not dead, but dreaming, and we are the dreamers, awake at last to the wonder and the terror of what might be. So we listen and we look and we hope. The story of exoplanetary anomalies is still being written, one observation at a time, one question at a time, one wonder at a time. It is a story without an ending, and that perhaps is its greatest gift. For in the search itself, in the act of looking outward, of listening for echoes, of seeking kinship in the stars, we fulfill our deepest longing, to know, to remember, to be part of something larger than ourselves. The universe whispers and we answer, not with certainty, but with hope. And in that hope, we are never truly alone.